Hey everyone, and I'm very delighted to tell a story about growing a Terraform provider and lessons learned for it, and how we got to 4 million downloads and more than 90% unit test coverage, and other fun things. I'm Serge Martin, and I'm the lead maintainer of Databricks Terraform Provider. And I worked on many different stages of data lifecycle over the course of past 15 years. And I worked in cyber threat security and built a couple of data science platforms from scratch. And my main job at Databricks is to grow strategic customers. So briefly about Databricks. Well, we are the Lakehouse platform. We define Lakehouse category. You're able to store all of your data, structured and unstructured, all in a single place. We bring the reliability and extremely high query performance to that data without leaving the data lake with an open technology called Delta Lake, so that you can use it for your all data warehousing workloads. Next, the Unity catalog provides the governance abilities so that you can have fine-grained governance and security for your data and AI. And you can do data warehousing, data engineering, and data science and machine learning in a simple, unified, built with open source technologies with open standards across all of the major clouds like Microsoft Azure, AWS, and Google Cloud. So briefly about Databricks Terraform Provider. It's a verified Terraform provider by as HashiCorp partner, and it's actually top 5% among all of the providers by a number of downloads, entities, contributors, and commits. Like we have more than 80 entities, and it includes resources and data resources, and it's growing because Databricks always adds new functionality. And we have more than 4 million downloads with 130,000 downloads every week. And the amount of code is approximately 76,000 lines of code. And there's a lot of reflection. So if we didn't use reflection, probably it will be way bigger. And 90% of that code is actually covered with the unit test coverage that runs for 40 seconds. And well, the first major thing is to tell you how a tiny bit of reflection won't actually hurt and can save like 50, 60% of boilerplate code. Like here is a minimal working Terraform provider. Like we have the package main, we import a couple of things, then we have a function that returns schema.provider. And every provider must have a schema to define and validate the configuration. And there is also the configure context func that configures the connectivity to the backends, which result is later returned into all of the resources as part of the meta. So essentially, once you are having your schemas and configuration for provider and resources, you perform callbacks, creates, reads, updates, deletes. And essentially, once you connect to the backend, you create a resource by setting the ID field to something that signifies Terraform. Well, yeah, okay, we have a resource for it. Well, all in all, that's the simplest Terraform provider that is completely useless because it doesn't do much. But we had to experiment a couple of things a couple of times when we're performing Terraform provider GitHub organization transfer. So you see pretty much of a lot of boilerplate code. So within Databricks Terraform provider, we had to set a goal as minimal boilerplate for everything. Like we need to work on making things work instead of writing some auxiliary code. So here is the code from one of our resources. It's called customer managed key. Essentially, we register customer managed key for storage in AWS cloud. And here we have a couple of interesting bits. So on the line struct to schema, we take a struct type and create a full Terraform schema with providing the ability to customize the schema. Then what we simply do, instead of setting the resource data for hundreds of lines, we just have one line, common data to struct pointer, where we provide a resource data, schema, and the empty type instance. Essentially, it's a very simple way just to set all of the relevant values from resource data into a data type without having to write hundreds of lines of data resource manipulation. Then reading that data is also simple. We do common struct the data, and given the CMK type instance and schema, we just set all of the relevant data fields, and it works. So overall, this is just approximately 60 lines of code to make a relatively generic resource. Normally, it used to be something like, I don't know, 500 lines minimum. So that saves a lot of time. But it has some drawbacks. So, for example, life is very easy for compatible schema changes because the only thing we have to do is add a line to a type that is already annotated with JSON type tags. And we've added additional type tag called TF, where we set things like computed, force new, and other things. Well, it's nice. But when we have to create things like state upgraders, we have to actually write it back as the normal schema in the code. So if you will think that reflection is panacea, it's not. It's just a way to move faster. But once you are doing some backwards incompatible changes, then yeah, it makes actually things a bit difficult. Well, all in all, benefits are tremendous because look at the job settings type. Like we have multiple different fields with multiple different configuration blocks, and we have the simplified validation type. So essentially, when one field is there, then other fields must not be there, etc., etc., etc. So for very complicated resources, this actually saves a lot of time, a lot of cycles for us to maintain the provider. And whenever reflection cannot cope with the schema structure we wanted to cope, we just provide a second argument to struct the schema function that just modifies the schema into the shape we want by adding more fields, by changing validation for those fields, and things like that. So as you see, we have the common overlay on top of Terraform SDK. What else do we have there? First of all, we are catching all of the panics in the recoverable callback. So that's whenever there's a panic in create, read, update, or delete, we actually present it as a normal error. More on that on the later slides. Then we generically handle the cleanup of resources from Terraform state when they were removed on the backend. Because as you know, from Terraform SDK, whenever the resource is removed on the backend, you have to set ID to the empty string in order to remove this resource in the Terraform state. And the other things we do here is just nicer error handling, like, okay, cannot create job, cannot update cluster policy, cannot delete workspace configuration, and so on, and so on, and so on. Like, we just add a prefix to all of the errors so that users are more confident by looking documentation or contacting our support when things don't work as user expect. The other thing we do in the common resource is reconciliation of state drift. So as you know, Terraform SDK recommends to call read callback every time you do create or update. Well, we hide it in the two resource, common resource, and normal resource developers of this provider don't have to be calling read callback, making code way simpler to work with, way more testable, and allowing us to focus on writing the code that's needed and not actually making the reconciliation work. So that saves a lot of time also for importing the resources, because as you know, like by default, the importer for resources does not work. You have to explicitly define it, and we define importer for 98% of our resources, and it just works out of the box. For some things, we cannot really import into Terraform state, so we disable importer. That's essentially how we work with common resources. Like another interesting use of modern GoLang ecosystem is context.WithValue. We use it to actually augment our user agent string for the provider that calls our APIs and provide in the resource name that is actually used. Why it's so important? Can't we just infer it from the API call? Well, not quite, because lots of resources at Databricks call more than one kind of API, and like those could be creating a mount. Creating a mount creates a command, creates a cluster, and then waits for cluster is up and running. So essentially, call like 5 different APIs. And we didn't know before, like, okay, what kinds of mounts were there and how many actual customers were using mounts. So we invested a lot into actually telemetry and understanding how this provider is used in order to focus on the user experience and provide the best possible convenience for users. And obviously, we were focusing on the things that we use the most. Otherwise, it would not have making much sense. So essentially, context.WithValue is set on the provider configuration startup level, and it sets the resource name to all of resources and data sources that are propagated down as a name to the user agent string, which also holds the Terraform provider, the Terraform version itself, because we need to know, like, are customers using Terraform 1.1, 1.2, 1.0, 0.13, and so on and so on and so on. Like, still, some customers are using 0.12 and 0.11. So they are there, and they will be there. So this helps a lot. Then other interesting thing I'm very proud is reverse engineering the deployments for customers who don't have infrastructure as a code yet. Like essentially, it's a very complicated tooling that just looks at your existing Databricks Git repositories or clusters or other things and generates the HCL code for those, so that when customer is preparing for disaster recovery exercise, they can go invoke this Terraform exporter functionality and have HCL code TF files generated for all of resources that they've manually created for Databricks before, and have it all managed through version control through Terraform. Isn't it awesome? Well, it's actually awesome. And adding support for new type of resource for code generation is not that difficult. Here you see Databricks repo, and you have a couple of fields to define there, like defining service, defining the name of the resource callback, and then very interesting callback called listing. Essentially, listing is just the breadth first search that iterates through all of the repos and emits the entities that are there, sometimes matching the search criteria. And then there is another callback, post importing, which is essentially after we call the read context callback of Terraform resource, we also add things like permissions for this Git repository. Essentially, there is a command called Terraform add that tries to be baked into the Terraform core, but there is no listing. So once HashiCorp would implement something generic into their toolkits, yeah, I would be happy to pour this framework to something more generic, because there are plenty of tools similar like that, like AskTFI, Terraforming, Terraformer, or Terracognita. Why I decided to create yet another tooling for this? Well, first of all, there was nothing like that to support Databricks. Then it was easier to ship it in the same binary, just as another command. And I wanted to focus on the readable code. Like, here's the example for referential integrity resolution. Like, we generate the code for instance profile for a group, but then we have a resource that binds instance profile with a group. And by default, in a generated way, we just have plain text IDs. But the exporter functionality defines a relationship between different resources in the depends block that it is able to replace the plain text identifiers with resource references, essentially making it very nice, simple, readable, navigatable code with Visual Studio Code for Terraform extension. Essentially, that's great. And whenever you are using Databricks, you should use, and not yet using Terraform, but want to, you should use Terraform Exporter to generate the code. Then another interesting thing that we have in Terraform Provider is the HTTP Fixture Framework. It's a strange testing technique that actually saves plethora of time. So how it works? For example, here we have a test something existing. So we define QA, HTTP fixture, and we want to work with pure TDD. So that's the single test we write with some HCL configuration in, and we test the create phase of a catalog resource. That's it. Essentially, we run this test, and obviously it fails. Well, okay, what's so new about it? The good thing about it is that the failure almost fixes itself. It gives you the error as follows: missing stub, please add. And then it provides you with almost working code generated by heuristics so that you can take it and copy paste it into a test, change the response types and request types, then it works. So here is like the real example of the test. We have test catalog create also deletes default schema. We have a set of 3 fixtures. The first fixture, which is a call of HTTP post method to API 2.0 Unity catalogs path with catalog info entity with name A, comment B, with properties C equals to D. Then we execute delete on another HTTP path, and then we execute get. So essentially, these are all things that these are all HTTP requests that are performed in the scope of create callback of Terraform resource, and we capture them in a single test that is debuggable and that is readable. Because we use these tests also as documentation. Because it takes a couple of seconds just to find the test, find the corner case, and just see what APIs it calls. And maybe engineer doesn't know Terraform structure at all, but them seeing this test actually explains a lot. And oh yeah, I know where's the bug, and they are able to copy paste this test, reproduce the failure conditions, and debug it, and work their way out to the resolution way quicker than with any other technique. Essentially, with debug test button in the Visual Studio Code, we're able to save tremendous amounts of time and have confidence in fixing issues or implementing functionality. So I totally recommend using the similar technique. Unit tests actually have very good correlation with the adoption. So here we have 2 charts. On the top, we have the trend of unit test coverage. And on the bottom, we have the relative adoption trend. And as you see, it takes approximately 2-3 months, or it took approximately 2-3 months for adoption to pick up after the tests were added, after the test coverage was actually increased greatly. And yeah, test coverage is more than 90% now. It's very reasonable. It's very high, considering the fact that most of Terraform providers rely mostly on acceptance tests. But I mean, come on, acceptance tests take, I don't know, hours to run. This takes 40 seconds to run and allows us to iterate fast, launch fast, and don't stop until we're done. So whenever you want to make something that's used a lot and installed, yeah, make sure it has a lot of unit test coverage, like more than 90%, because it really reflects well on the adoption of something installable like Terraform Provider. But there are more things than just tests. Like Dependabot is awesome. Like we've been using it since early 2021, and yeah, it has made like more than 100 commits. It's like, what is Dependabot? Dependabot is something that looks at your dependency file, like GoMod, and finds newer versions of those dependencies and issues pull requests to your repository, sometimes also telling you, oh, okay, here are two files changed, GoMod and GoSum, and here's the changelog for this version. Yeah, please read it, please approve it. And by the way, we've run all of the unit tests for it, so yeah, it's completely safe to merge this pull request with updated dependencies. Yeah, like it's awesome because Dependabot does the course of maintaining the dependencies and making sure they are up to date, that security patches are fixed, that new functionality is added, and that's development is not stale. It's great until it's not, because like once we received an issue, hey, 0.38 plugin crashed, and we actually found out that there was an issue in the Terraform SDK for the happy path that was not covered by unit tests. So essentially, Terraform SDK version 2.8.0 added a functionality for data resource that was checking for something that was not there, essentially going to the nil pointer. So it was all-time favorite null pointer exception equivalent in Go. And yeah, it was panicking. It was crashing the providers. And after this, I really decided to add the recoverable callback to catch all of the panics and check it. So yeah, it would have caught this. Also, the other thing that could help to caught this would have been the acceptance testing for everything. But acceptance testing of Databricks Terraform Provider is a bit more complicated than others. Right? Well, we support all of the major clouds like Azure, AWS, and GCP. On Azure, Azure M Provider creates Databricks workspaces, but for AWS and GCP, yeah, this provider creates workspaces. And there is another code path and authentication flow for creation of workspaces there. Then every cloud has its own peculiar ways of authenticating, like Azure Managed Server Identity Authentication or client secrets for service principals, or Azure CLI authentication to reuse the access token locally created by IEZ login tool, the same for Google. And for AWS, we also integrate with a couple of other techniques. And we also have Databricks CLI, so we want to reuse the authentication from there. And yeah, you will see that's amount of our integration testing for acceptance of the provider is quite high. And we are working on running it more frequently, optimizing the runtimes and architecture. So this is how it's currently done. But eventually it will be something either simpler or more complex. Yeah. Anyway, we are working on making sure that all of the acceptance tests are running more frequently, because it takes hours to run this, and it takes just 40 seconds to run 1,200 unit tests to give us 91% confidence in the validity of a code change. Then the other thing we've started doing recently is to add so-called architecture fitness function, where we just check that, okay, every resource must have more than 80% of fields documented, more than 60% of fields unit tested, more than 80% of fields acceptance tested, and all files have to follow same conventions, etc., etc., etc. Because like we have very limited amount of time for like supporting this. We do many things, and yeah, we want to enable all of the contributors that help maintaining this provider to follow the standards. Sometimes they don't know the standards, so we are working on ways to make sure that's contributing to provider is easy, and that's all of the things are followed. And we try to automate as much as possible, and we try to have internal reporting as good as possible, and we try to focus and use data-driven decision-making process to actually improve this provider and build roadmap. So that's how we maintain a Terraform provider for Databricks. And I'm very excited to hear any feedback. So go to GitHub and create an issue or discussion, and happy that you start using it. And or I'm very happy that you learned some of new techniques from this talk. Thank you. Sorry, Smerting from Databricks Amsterdam. We are hiring. Bye.